Good morning, everybody. Happy Wednesday to you all. Is it Wednesday today? Yeah, it is, isn't it? Yeah. I hope we're all doing well, and I hope you're keeping yourself fit and healthy out there and just trying your best to keep yourself busy in these difficult times. Thank you for clicking on this video. I would like to deliver a bit of a virtual lesson this morning all about the subject of the night sky and astronomy. Now, I love this subject, literally love this subject to pieces. I can't stop talking about the universe, space, planets, life in the universe, and you might be like me. And children, if you're watching this video clip, you may be fascinated to learn a bit more about the night sky as well. And so what I'm going to do is teach you a little bit about the night sky and what we know about stars and what we know about studying the night sky as well. And we're going to go through a little presentation here on the screen. Feel free at any point to post some questions below the video today, and I will do my best to get back to you. Maybe you could ask me your best space question. You've always got a fascinating space fact that you wish to share with me, or you've always wanted to know something about space, or maybe now is the time to have a go at doing this, and just post that little comment and question below. So we're going to have a little look at what it's all about and why studying the night sky is so important to us. Well, when I was young, I used to really love looking up at the night sky, and I still do to this day. And I think that I've managed to carry on that love of learning about astronomy for all these years. And a bit like you can see here, these two children pointing and looking at the night sky and wondering what those stars are, what patterns they're making in the night sky, why they're so special, and what are they teaching us about kind of the universe, about where we live. And we're not the only people who have been doing that. In fact, people have been looking at the night sky for hundreds and hundreds of years. You can see two images here on the screen. One on the left is of a famous astronomer. We refer to him as Galileo. Those of you at school at the moment may have heard of Galileo. You may have done a little bit of work about who he is. Perhaps if you've been learning about Earth, Sun and the Moon in year 5, maybe you've been studying about famous scientists, and maybe Galileo has come up on your list. And I don't know if you can see here, but Galileo is looking through an object. And the object he's looking through is a telescope. And maybe you knew that and you're shouting out, oh, that's a telescope. Well done if you did. But look what he's doing. He's also drawing, he's sketching what he sees through his telescope. Now, this was a long time ago. This was 400 to 500 years ago in the past. And Galileo back then, they didn't have fantastic telescopes. They had just very, very simple telescopes. And with a simple telescope, Galileo was able to discover these amazing things about the night sky. He could see planets, he could see patterns of stars, he could see the moon in great detail. And Galileo wasn't the only person to do that. You can see on the right here that this had been thought about before. Lots of people in ancient Greece were studying the night sky and coming up with ideas about what star patterns meant and putting their own myths and folklore into the night sky to really give them kind of like meaning, so that perhaps they meant something to people of that time. How do we know all of this? Well, we've got evidence for it. We've got writings captured from the past, we've got sketches on stone tablets, we've got prints and even cave paintings on the walls of ancient early humans as well. So we know that people have been interested in the night sky for lots and lots and lots of years before we started studying it today. Now, this is a pretty big telescope, isn't it? And have a look at this. This is a sketch done of one of my favourite people who study the night sky of all time. We tend to call people who study the night sky astronomers. And astronomers are people who use telescopes, binoculars, or even their eyes to look up at the night sky and ask questions and wonder where all of those things come from, and wonder why a star looks like that or why a planet looks like this. And then they go away and talk to other people about their discoveries, and that makes you an astronomer. So if it's clear tonight, go outside and have a look at the night sky. You too can become an astronomer. It's that easy to do. This is a picture of our famous astronomer William Herschel. You can see his name written up here in the top left. And these are one of William's telescopes that he built in his garden. William was quite famous for building large telescopes. This is his 20-foot telescope. I mean, it's pretty big. You can see it really needs some scaffolding to hold the telescope up. It even needs people to help operate, to move the telescope up and move it down. A lot bigger than the telescope that Galileo used. But this telescope is slightly different. And in a moment, I'm going to teach you about the two different types of telescopes. But if you thought that was big, what about this one? Wow. This again is another one of William Herschel's telescopes. You can see at the top here, Herschel's Grand Telescope. Now, this was his 40-foot telescope. This was a beast. Absolutely huge. Apologies if now and again you hear a little bleep going off in the background. This telescope was absolutely massive. And with this telescope, William Herschel was able to make some amazing discoveries in the night sky. He would use his telescope and he would look for nebulas in the night sky. He would try and look for fuzzy patches. And he was trying to discover new things. And he didn't do it alone. He did it with his sister over here called Caroline. And Caroline herself became an amazing astronomer. In fact, girls, if you're watching this now, believe in yourself that you too can become this incredible young scientist when you grow up. And you still are now when you're learning science at home, even by watching this video. Caroline used to study comets, and those are icy objects that fly around in space. They come from the very outer edges of the solar system, and they fly all the way into the solar system. And Caroline went on to become the first paid female astronomer of the time. I mean, that's pretty cool, isn't it? To have that kind of prestigious kind of award given to you. So what do you do if you start using telescopes to look at the night sky? Well, of course, you could start drawing, you could start sketching. These are some of Galileo's sketches that we mentioned a few moments back. Sketches of the moon. You can see on the right hand side here, these circles you can see. Hopefully you're picking this up on my mouse. This is the planet Jupiter, and these little stars at the side of it, these are the moons of Jupiter. So planets in space also have moons, just like our Earth has a moon. Other planets also have moons as well. And Jupiter has its own set of moons. It has quite a lot of them, actually. But you can see those moons moving around the planet Jupiter through a telescope, which is kind of cool. And we know that Jupiter is a huge ball, a planet, huge gaseous planet in space. You could fit about 1,000 Earths inside of Jupiter. It is that big. And it's an incredible swirling vortex of gases and fluids deep down inside. And even in the middle, we think there might even be a core to Jupiter's planet as well. And we're still learning about this planet every single year. And it's fascinating to see. Now you can see these two pictures here. Here's a close-up picture of the planet Jupiter. If you were to look through a very powerful telescope, you might be able to see some of the patterns going around the side of the planet. And you can see this circle motion here as well. This is what we call a great red spot. But through a small telescope, maybe Jupiter might not look as impressive, but you can still see a bright object and these little dots along the side. And these little dots along the side are the moons that are going around the planet Jupiter, just like in Galileo's sketches here. Now, I don't know about you, but that's pretty cool. He was seeing moons going around a planet almost 500 years ago. Now, I've pushed on about telescopes, haven't I? Instead, they're really amazing. You can use them to look into space, absolutely. But don't forget the amazing things you already have, your eyes. Your eyes are brilliant for studying the night sky. Think about how they're designed. Think about all the vision that you can see. Just look around the room right now. You can see all the way to the left or all the way to the right. You can see up, you can see down. Your eyes are designed to capture as much light as possible. And when we go outside at night to look at the night sky, it's important that we know that our eyes are a really good tool to use. Now, when you do go outside, one of the things I want you to do is don't expect to just look straight up and go, wow, look at all those stars. Give yourself a bit of time for your eyes to become adjusted, between about 10 to 20 minutes. Usually if you're wrapped up nice and warm, you've got a drink in your hand, because the more you allow your eyes to become what we call dark adapted, the more light you're going to see. And in astronomy, we talk a lot about being able to see things that are really faint and difficult to pick out. And we put them on this scale here. Can you see this ruler scale here? So on the right here, we've got things that are very, very faint to see, things that you would need the big space telescope to detect. And then things over on the left here are the things we can easily see, like the sun. It's really bright. We can see the sun, can't we? We might be able to see the full moon. That's really bright as well. Maybe you can even see the bright planet Venus, which is currently out at the moment, just in the same direction after the sun sets. And I'm making a video on that later this week. But then maybe you start to see more stars the longer you allow your eyes to become adapted to the night sky. Now, unfortunately, where you sometimes live might be a bit of a problem. This is where I live in the West Midlands. And look at all this colour. You may think that looks quite pretty. It's not really. This is what we call light pollution. This is caused by street lights and houses leaving their lights on and shops leaving their lights on. And unfortunately, all that light pours out of those buildings and goes into the night sky. And when it goes into the night sky, it stops us from being able to see as many stars. Quite annoying, isn't it? So what can we do about it? Well, we can turn things off. If we're not using anything, such as a bedroom light or a bathroom light, we can turn it off. We can encourage people to save electricity and save a bit of energy, because the more of those lights we can turn off, the more of the night sky we're likely to see. And it's not just where I live, it's in the world as well. Have a look at this map across the world of light pollution. I mean, it's pretty shocking, isn't it? And you can see here how it changes from the 1950s through to the 1970s, 1990s, and even in the future, 2025, which isn't too far away now, we predict that our light pollution problems might get even worse. And so you young people listening to this video now, you need to help make these changes happen. Help protecting our country, protecting our environment, and protecting our night sky, because then we're able to see more in the night sky. Because we don't want our world to be covered in unnecessary light pollution, because that's going to make it harder and harder for us to be able to see the night sky. Now, when you're stuck indoors at the moment, and you're thinking, okay, what can I do to get myself ready? Well, tonight is predicted to be a clear night. Woo! Which is very rare when talking about astronomy in the UK, a clear night. Now, I like to use apps. So I've got my phone here. If I just open it up for a moment, you'll see, if I can just show you on my screen, I have a folder called an astronomy folder. Everybody should have an astronomy folder. And I've got lots of apps inside my folder. And all of these apps pretty much are free. So on the screen, you can see some of these apps, the Met Office, BBC Weather, there's a compass, there's an app that tells me what the stars are in the night sky. And I use these apps to help me figure out whether the weather is going to be good to do stargazing or not. For example, I might click on this one here for the BBC, and it tells me where I live tonight, and hopefully you can pick this out, that tonight it looks like it's going to be a clear night. There's lots of moons, which is good. Now I need to know what time the sun's going to set, and it says on here the sun's going down about 6:30. So sometimes it might be a little bit late for you to be outside all night to see the stars, but when the sun goes down, go out and have a look and see what you can see. Can you see the bright star Venus just in the same direction where the sun's setting? Can you see any stars at all? Can you see how the colours change as the sun goes down? And we call it the blue hour. It's a really beautiful colour of the night sky. And once you start getting into this topic a little bit more, you'll start seeing here on the screen there's some specialist apps that tell us even more about where to look, what phase the moon is in on this night, and what time the sun goes to bed at night, and what time it wakes up in the morning as well. And so I encourage you to go out there and have a little play with these. Now, if you can do one thing today to prepare yourself for the night sky, have a look at a program called Stellarium. And I'll show that at the end of this webcast, just to show you how you can download this. But Stellarium is a free program on your computer or on your phone, which allows you to simulate what the night sky looks like above your house. It's really addictive and it's really powerful. So have a look at getting yourself an app or this program called Stellarium. And you can download it and you can have a play around, and you can move the sliders around to see what the night sky would look like above your house. And it's a really good way of starting to see what bright stars exist above you, or what patterns exist above you in the night sky. Because in astronomy, we tend to find patterns wherever we look. Take these 3 patterns of stars. The one on the left here, hopefully my mouse is showing up on this webcast, you can see there's a bit of a shape here, and I'm going to teach you something. This is a constellation that we call the Plough, or sometimes we call it the Great Bear, or its official name of Ursa Major. Now I want you to imagine this shape here. Take these 4 stars, 1, 2, 3, 4 at the bottom right, and imagine then there's a box. Now draw an imaginary line up here to this next star, to the one in the middle, and then to the one down here. You see that kind of looks like a handle and a saucepan on the bottom. So it's almost like a bowl with a handle on the side. So that's a really familiar shape to look out for. And I know when I go outside currently and I look up, I can see this shape directly above my house. It's almost on its side. So I'm seeing a constellation of stars. Now we're just leaving the winter period, but you can still see this one below. This is called Orion, which has its trademark 3 stars in the middle. We call this the Orion's Belt. And just below the Orion's Belt, there's a really interesting area where new stars are born all the time. We call this area a nebula. Now, what's cool about Orion is, can you see the different colours? So can you see how some of the stars in the middle are a little bit bluish? This one down in the bottom right is a slightly different tinge of blue, but in the top left, it's almost like an orangey red coloured star. Have a think about why that might be. Over on the right over here, you can see another constellation of stars. We call this Cassiopeia. This is kind of like a sidewards W or a sidewards M, depending on which way you're looking at it. But let's trace a line across with my mouse. So I'm going to go down from this top left star to the middle, up to the middle again, down again, and up to the side. We've got this kind of W pattern of stars going on. And again, look, the star here, this is interesting. It's almost a similar colour to this star over here, just a little bit faded. Well, stars are different colours. They're not all white. Stars are different colours based on how hot they are. That's interesting, isn't it? Stars can be hot or they can be a little bit cooler. Now, we wouldn't say that a star is cold because it's a burning ball of hot gas, but their temperatures can change. And some stars, as they grow through their lives, their temperature changes. And that means their colour that they give off changes as well. We tend to find those younger looking stars more towards the bluish colour, and those older stars tend to be more toward the orange and reds in colour as well. And that's quite interesting. When we look at the night sky, we're looking not only for patterns and shapes of stars, but also colours of stars as well. Now, one thing I'd like you to try and do, and I've got this app on my phone, again, just to share with you, this is an app called Sputnik. And Sputnik is an app, and I'm just opening mine up here on my phone. There it is. It may look similar to one that you've got on your screen. Is a free app that tells you when the International Space Station, which is this down here in the bottom right, a space laboratory, is flying over your house. Now, I can see on my app that I've downloaded that I've clicked a button here, and it says that tonight at 7:38, the International Space Station will fly over my house. It tells me which direction to look. It tells me I need to be facing west, and I can use my compass to find which way is west. And it should be passing over the top of my house. And it says on here that it's not going to be terribly high. It's only going to be just above the horizon, but I might be able to, if I've got a clear horizon, just see it rising and passing. And what would it actually look like? Well, it's actually going to end up looking a little bit like a bright star that gets a bit brighter as it travels across the sky and then fades a little bit as it drifts off. You are looking at a space station flying above your house. I mean, how cool is that? Where astronauts live and work on this space station. Huge, flying around the Earth. Such an amazing thing to be part of, to say, I can see a space station flying over my house. So download the app Sputnik and have a little look to see if we can figure it out. Now, if you do decide to head outside in the next few nights and have a look at the night sky, what could be useful to help you? Well, star guides are really good, and these are something you can find on the internet by just typing in star guides, and you can download them and print them. You can use what we call planispheres, which are these wheels in the middle, which are relatively cheap these days to order online, or you can even make one of yourself using a downloadable document, which I'll try and put below this webcast today. But one of the things I'd really want to stress, which is really important, is when you go outside, try not to use your mobile phone, because it's going to affect your vision, and you've just got it perfected for looking at the night sky, and now your eyes are all like, oh, I've blinded myself with my phone light, I can't see anything. Try and get yourself a torch that has a red light. In astronomy, we tend to say that red light doesn't affect your night vision. And even if you've got a regular torch, find a piece of red cellophane, something from like an old sweet wrapper, and wrap it over the top of your torch and put a hair bobble or elastic band over the top, and it will change that colour light to red. We're trying to keep our night adaptation as perfect as possible. And another good thing I like to say to my students is maybe grab yourself a book, maybe you've got one already in your house, or maybe there's an ebook on your Kindle or on your iPad. Or perhaps an opportunity to download a magazine. If you're lucky to get to one of the supermarkets for an essential run currently, and you're there and you get to go into the science section, have a look to see if you can find any science magazines, such as The Sky at Night, which gives you a monthly guide to what's up in the night sky every single month. And a couple of my particular favourites I love are these books here. One is called Stargazing Secrets, and the other one is called Turn Left at Orion, which is a guide to helping you star hop from one stop to the next. These are all tools and little tips to help you just get into this subject a little bit more. Now, I'm going to just exit this presentation because I know that a lot of you out there might have access to a telescope, and I'd like to just show you something, if I may. So I'm going to open up here a digital whiteboard, and I'm going to make it full screen. And I'm going to draw a couple of things on it. So if you've got a pen and pad with you and you've been taking notes throughout this presentation, this might be a time where you either pause the video or you draw along with me. So the first thing I'm going to do is I'm going to draw this. I'm going to draw a shape that looks like a squashed circle. In maths, we may refer to that as an ellipse. And I'm going to do it again, but this time I'm going to do it over here, like so. Now what I've drawn here are two lenses, and I'm just going to write that underneath. I'm going to write lens 1 there, and then over on this side I'm going to do the same again, and I'm going to write lens 2. Now lenses are pieces of glass, and glass that is found inside of a telescope we tend to call a refracting telescope. And so any science keywords I use, I'm just going to have a post-it note here, and I'm just going to write the word refracting. Okay, refracting in physics and science means bending of light or slowing of light as it goes through one object through to another. So what I'm going to do is take a pen, and I'm going to change the colour, and let's put yellow on so we can mimic starlight. What I'm going to do is pass a beam of starlight through this first lens, and as it goes through this first lens is going to bend the light down towards the second lens, like so. And then I'm going to put another beam of light in over here. It's going to go through the lens again, and it's going to bend it towards this second lens over here, like so. Now with these lines we call waves of light or lines of light. Imagine this is starlight travelling through your telescope, and of course these lenses are inside of a telescope. So if I imagine now that, let's put a big line on top here, this is my tube of my telescope, so there's the top part of my telescope, and there's the bottom part of my telescope, and inside of my telescope I've got these two lenses, one at the front, one at the back. Well, these lenses are collecting light, and as they collect light they bend them down to a particular point, and we tend to refer to this particular point down here. And I'm just going to add my text box again here, and let's see if we can make this work. So I'm going to click on my text here, pop it there, and we're going to call this a focal point. So this is the point where all of our light gets focused, and we tend to then in astronomy put something else on the end here. We tend to put a little eyepiece, so something that we can, at the end of our telescope, we can kind of focus things in. So I'll put my little eyepiece on the end here, and this lens usually is found inside of this eyepiece, which is on the end of your telescope, and you can usually move that little bit of a lens in and out, and it helps you bring your image into focus. Now this is one type of telescope. We call this a refracting telescope, and I can move this around a bit, which is quite cool on this software, as you can see here. I'm just going to go to my other page now, and I'm going to go back to my pen, and this time I'm going to select this pen. I'm going to select let's go for a blue in colour this time, and this time I'm going to draw this. Instead of drawing a lens, I'm going to draw a curved shape over here, and I'm going to write next to it, and this time it's not a lens anymore, it's a mirror. And here is my starlight again. Oh, actually, let's put the tube on. So here's the tube of my telescope. So let's go back again. Black. Here we go. So this time I've got a tube of my telescope once again, just like before. So putting my tube of my telescope on there. So all my starlight is going to be coming down through my tube. So I'm going to go back to yellow for my starlight. So here it comes. It's going to be traveling all the way down towards my mirror. Might even put a couple of little arrows on as well, just to show that that's the direction that the starlight is moving in. And I like to put another one over here as well. So again, pop some arrows on. There we go, like so. Now when it gets to the mirror, this mirror is curved. It has a funny shape to it. So it's going to bounce the light back into the middle. And so I'm going to do this now. I'm going to put some arrows on here, like so. I'm going to put some arrows on here. I'm going to put some arrows on here. And so all my starlight is now not going through a lens, but it's being bounced from a mirror. Now, where's that going to go? What's that going to do? Well, it's just going to come back out of the tube. And we don't want that to happen, do we? So I'm going to need to add something. And so I'm going to add another mirror here. And if you've been studying angles in maths, you may know that this is a 45-degree angle. There we go. And when the starlight hits this secondary mirror, it's going to bounce off this mirror, whoop, straight up and out the side of the telescope. And it just so happens that there is a gap at the side of the telescope here. And that's where you look. You look through an eyepiece at the side of your telescope here to see the starlight that comes in this way. Now, this type of telescope we don't call a refracting telescope, we call a reflecting telescope because it uses a mirror to reflect light. So I wanted to share that with you, just a little bit about how these telescopes work, because often when you see pictures of telescopes like these, you might see these words like refracting telescope, and that's because it has a lens at the front and a lens at the back, and the light gets bent slowly as it goes through. And then this telescope, which has a mirror at the back and a mirror in the middle, and look how this telescope's different. You look in through the side rather than looking through the bottom of the telescope. That's because this telescope is made using mirrors instead of using lenses. And then you get this on the right. Oh my life, what's this all about with computer controls? Well, that's a little bit of both. It has a little bit of both of these blended in. A little bit more for the advanced astronomer to be using one of those telescopes. Now, when we go outside for the night sky, let's get our eyes ready and adjusted, because you can see here on the left are two amazing pictures of things that live in the night sky. And you may be going out thinking, wow, I can't wait, I'm about to look at this. This is going to be amazing. But when you get outside, it really looks like this on the right-hand side, or like this down here. Now, don't be disappointed with those. Your eyes are slightly designed differently to how perhaps a camera might be. And these pictures on the left have been photographed, and those pictures on the right are looking through a telescope with your eyes. So you'll notice there will be a bit of a difference with what you see, but don't be put off by that. Just imagine that whatever you see through your telescope, you're looking at something usually hundreds, even not millions of light years away. So we are encouraging students around the country to, whenever there is a clear night, get outside and have a look at the stars. See if you can see some of those colours of stars. See if you can pick out some of those patterns using a downloadable star guide. I'll post one in the comments below. See if you can see all those different colours of those stars as well. And see if you can start to develop your inner astronomer as well. Thank you so much for being part of this virtual lesson today. You can play this back as many times as you wish. If you do any follow-on work from this lesson today, please post it in the comments below, whether that's making a really cool poster about astronomy and stars, whether that's going outside, wrapping up with your hot chocolate and ready to look at the night sky, or using some binoculars for the first time. Astronomy is something that we can start to all get into. Now we're spending a little bit more time at home. Currently, the moon is in what we call a new moon phase, which means there is no moon for a few nights. So the night sky should be nice and clear, which means when the sun goes down, you should be able to see some stars. But again, it's about finding those patterns. Stay safe, everybody. Remember, if you're watching this, boys and girls, you are amazing. You are incredible. You are working so hard. Continue to love your learning you're doing with your mums and dads at home. And take care and keep checking on this page for more information with different lessons. And apart from that, have a wonderful day. Take care, everybody, and see you soon. Bye.